All right, guys, here's the notes on ions. Basically, it's all about calculating the number of electrons. Do this reasonably quickly. All right, so let's talk about what an ion is first. So first off, ions are atoms or groups of atoms with positive or negative charges. Okay, we'll talk later about what groups of atoms means, but basically it just means that these are atoms, unlike other ones we've looked at, where the number of protons and electrons are the same. Now we have a difference in the two, and that gives them either a positive or negative charge. So the first one is the formation of cations and anions. So a cation is formed when you take away an electron from an atom. So the key thing is that taking away of electrons. That forms what we call a cation. If you add an electron, then you get an anion. Cations have a positive charge and anions have a negative charge. This always throws people off because it feels backwards. Normally we think of taking away, like if you have a negative person in your life, normally we think of taking away, we think of subtraction, and we think of adding, and it's a positive thing. But this is different because we're dealing with electrons, okay? So if you had a negative person in your life, and everyone seems to know like, oh yeah, person negative, a negative person in your life, and you remove them from your life becomes a more positive place, right? Or if you owe somebody money and then you owe somebody even more money, you're adding debt to your life. That makes your life more negative. So if we're taking away electrons, if they're leaving, now you have more protons. You do electrons, it's positive charge. And if you're adding electrons, then you're getting a negative charge. Okay? And we write these differently. To tell the difference between an atom and an ion, we write the charge. So chlorine, calcium, is Ca2+. That's a calcium ion. Regular calcium is just Ca. So we put the charge in the corner. Now I write it technically both. Online, you'll see both as 2+ or as +2. I would prefer that you use 2+ because this is implying that it's two positives, okay? Just like 2- versus -2, this is more clear because we're not adding or subtracting anything here because actually to get a negative charge, you've added more electrons. This is saying you have 2 minuses and 2 pluses. I'm thinking the same way if we put 2x, you'd put 2x rather than x2, right? Because this is 2 of the 2 x's rather than times 2. So we put the number first. If it's got a single charge, like in the example here, if you had Na, you could do it as Na+, or sometimes you'll see it as Na1+. This is normally an easier way to do it. So forming cations. A cation forms when you lose an electron or more than one. So a neutral atom of magnesium has 12 protons and 12 electrons. If we take away 2 electrons, now we have a charge of 2+. And an anion forms when you gain an electron. So fluorine normally has 9 protons and 9 electrons, so it's got no charge. If you take away an electron, now you get fluorine minus. And so the other thing is to think about in general, metals form positive ions and nonmetals form negative ions. And if you picture the periodic table, most of the periodic table is metals. In fact, almost all of these are. These are all metals. And so almost this whole side of the periodic table forms cations, have a positive charge, while gases, this side of the periodic table is mainly nonmetals, and they form anions. There's some exceptions, like hydrogen's over here, and hydrogen forms a cation even though it's a nonmetal. And then there are these weird ones in the middle. These are called the metalloids. We'll talk more about them later. They kind of do a little bit of both. They mainly form cations, but it's, as a rule of thumb, if it's a metal, it's going to get a positive charge. If it's a non-metal, it's going to have a negative charge. So this is the key equation you need to remember for ionic charge. Charge is equal to the number of protons minus the number of electrons. Okay, and please note, using algebra, you can change this any way. If you know one of these, you know all of it. So if I tell you you have a charge of 2 plus, and you know that you have, let's say it's magnesium, so magnesium is atomic number 12, so we have 12 protons, so 2 equals 12 minus x. That's how you can know that x has to equal 10. Okay, or if I say you have a charge of 2 minus, and you have come up with a good number, 10 electrons, you know, negative 2 equals x minus 10, so you know that x has to equal 8 protons, so that means it was oxygen, the 2 minus. So you should be able to manipulate this equation algebraically to solve for any of these 3 variables. So let's do a couple. Okay, so we have 3 ions right here. Let's take care of it. So please know this is a symbol for protons, neutrons, and electrons. The number of protons, you should remember, is equal to the atomic number, so it's 19. Okay, and then we also know that mass is equal to protons plus neutrons. So if we have a mass of 39, 39 equals 19 minus neutrons, so 19 minus 39 is 20. Okay, so there's our protons and neutrons. Now, when we look at this, we see that we have a charge of plus 1. So we remember that our equation is charge equals protons minus electrons. So we have a charge of 1 equals, and we have 19 protons, so minus something is going to give us 1. So 19 minus 18 gives you a charge of plus 1. Okay, oxygen. Actually, I want to keep that. Oxygen, we do the same way. It's got an atomic number of 8, so it's got 8 protons. It has a mass of 16. 16 minus 8, because proton is equal to 8. Now we have a charge of 2 minus, so 8 protons minus x equals negative 2. So we do our math, and we know that that's got to be 10. That's a really crappy 10. Sorry about that. That has to be 10. Okay. And we have calcium. Calcium's got an atomic number of 20. It's got a mass of 41, so 41 minus 20 is 21. And then we have a charge of 2 plus, so 2 is equal to 20 minus x. This tells you that it also has to be 18 electrons. And oh, here's a fun little hint. There's going to be a reason we're going to hit it next unit why both of these form ions that have 18 electrons, but we'll save that for a future unit. So I hope that helps.